You know that moment you walk into, like, a massive sports bar or
Or a high-tech control center, yeah.
exactly, and you're just faced with this gigantic, flawless wall of screens acting as one single image.
Right, and you just assume there's some supercomputer humming in a back room somewhere keeping it all together.
I mean, I always did. But today, we're doing a deep dive into the hidden tech behind those synchronized video walls. We're looking at a bunch of AV diagrams and manuals, specifically focusing on the WolfPack 1x9 video wall processor.
Yeah, which is honestly fascinating because for about $900, a single piece of hardware like this runs 9 separate TVs.
9 TVs from one box.
Yeah.
And, to understand how it manages all those screens, you actually have to look at what it lacks, right?
Oh, absolutely. There is zero complex software involved here. None.
Wait, really? Like none at all?
Nope. The whole system relies on being 100% plug-and-play hardware. You just plug in a single input, like a 1080p HDMI cable, or even a direct USB drive.
Okay, let's unpack this. Because how does it instantly scale that image across the entire grid without a computer doing the math?
So think of it like a perfectly choreographed hardware-level pizza slicer.
A pizza slicer. Okay, I like that.
Yeah, because it isn't relying on an operating system, there are no background processes. So no lagging, no buffering, no crashing.
It just instantly slices one HD video into 9 pieces.
Exactly. The physical circuitry just splits and routes the video signal exactly where it needs to go in real time.
But slicing the digital video is only half the battle, though, because you still have the physical TV frames, the bezels getting in the way.
Right. The physical world always complicates things.
Yeah, wouldn't routing the image perfectly just leave you with this giant window pane effect, like literally stretching out the guy throwing the football?
It would, which is where the hardware engineering steps in.
Yeah.
Devices like this use what's called built-in bezel compensation.
So it actually accounts for the plastic frames.
Precisely. The hardware physically calculates the blind spot created by the TV frames and drops those overlapping pixels out of the image.
Oh, wow. So the proportions stay realistic.
Exactly. And it can power dozens of layout configurations like a 3x3 or a 2x4 grid. But to fight those physical borders, there's actually a bizarre workaround in the manuals.
Here's where it gets really interesting, by the way, because it supports 180-degree screen rotation.
Yeah, flipping the screens upside down.
Which sounds crazy. Why on earth would you mount TVs upside down? Is it because TVs generally have thicker bezels at the bottom?
You hit the nail on the head. Think about a standard off-the-shelf TV. The thickest part of the frame is almost always at the bottom where the brand logo lives.
Right, of course. So by flipping the top row of your grid upside down,
You force those ultra-thin top bezels to meet in the middle. It creates a nearly invisible seam between the screens.
that is incredibly clever. So the processor just flips the video signal 180 degrees for those specific top screens.
Yep, so the picture still looks completely right side up to you.
That physical workaround is brilliant. But, I mean, it relies entirely on that 9-screen limit. If I'm outfitting a massive venue, 9 screens won't cut it.
No, probably not.
So how do you scale past that hard limit without buying a supercomputer?
Well, you infinitely expand the wall through daisy chaining.
Daisy chaining.
Right, you literally take the HDMI output of your first processor and feed it right into the input of a second unit.
But wait, if there is absolutely zero software running this, how do the subsequent boxes know which piece of the massive image they're supposed to be displaying?
Oh, it's so simple. The first box just duplicates the master signal and hands it down the line.
Okay, and then?
Then you simply set a physical dial or switch on the second box to tell it, hey, you are managing grid number 2.
Just a mechanical switch.
Yep. Whether you are designing digital signage for a business or just dreaming up an insanely immersive multi-screen home theater for yourself, this module-based scaling is how you cheat the system.
You get the impact of an astronomically expensive stadium screen using standard TVs.
Exactly. You don't have to buy a single, massive, expensive screen.
So we're looking at software-free, instantaneous scaling, clever physical workarounds for thick bezels, and the ability to daisy chain to infinity.
It really takes the magic out of the supercomputer and puts it right into a straightforward box. Solves a highly complex problem using pure hardware mechanics.
It does. But, it makes you wonder about the future.
How so?
Well, we currently spend so much processing ingenuity to hide bezels and stitch these separate displays together into one perfect image.
Oh, for sure.
But if display manufacturing eventually eliminates bezels entirely, will we even need these complex processors to bridge the gaps?
That is a great point.
Yeah, or will the concept of a video wall simply become indistinguishable from a regular wall, Just something for you to think about the next time you're staring at the magic screen.